Hi students, this is Madhavi Madam Chemistry. First of all of you wish you happy Republic Day to all my students. So exams are coming now to prepare and enjoy your studies. So today I came you to discuss about important concept regarding class 12 CBSE and senior IPE, that is SN1 reactions and SN2 reactions from the organic chemistry. So if you like my video, please subscribe my channel and share and like my video. Okay, let us start our session. So today SN1 reactions and SN2 reactions from the organic chemistry. So from the organic chemistry, particularly from haloalkenes and haloarenes. Okay, now I want to explain the SN1 reactions and SN2 reactions. Explain. What is the question we are asking? Explain SN1 and SN2 reactions. SN1 and SN2 reactions. Okay, now this is important 8-mark questions they're asking in the IPE sessions. Okay, in the NEET and IIT also this is very important. The mechanism of SN1 and SN2. Okay, so let us see SN1 reaction. First, we have to see that SN1 reaction. What's the answer we want to explain? So, SN1 reactions. SN1 reactions. So, in SN1 reactions, we have to explain, we have to write as a point wise. So, first point, so SN1 means here, SN1 unimolecular nucleophilic substitution reactions. Okay, now SN1 means, okay, unimolecular nucleophilic substitution reactions. What is the meaning of SN1? Unimolecular nucleophilic substitution reaction. And the order of SN1 reactions is 1. Okay, now what is the order of SN1 reactions? 1. And the order of reactivity of SN1 reaction is tertiary alkyl halide is greater than secondary alkyl halide is greater than primary. This is very important. Okay, now. So if you take the order of reactivity of alkyl halides for the SN1 reaction, tertiary alkyl halide is greater than secondary alkyl is greater than primary alkyl halide. And here, the rate of reaction of SN1 reaction is depends only the concentration of reactants only. Only the concentration of reactants only. Okay, now. So in SN1 reaction, they will depend upon only the concentration of reactants only. Okay. And this SN1 reaction takes place in 2 steps. This will take place in 2 steps. Okay. First step, formation of step 1, formation of stable carbocation. And second step is formation of product through attack of nucleophile. Okay, attack of nucleophile. So let us take one example for this SN1 reaction. So here I am taking the example for the SN1 reaction, that is example I am taking here the example is tertiary alkyl halides, tertiary alkyl halides on hydrolysis gives tertiary alcohols. For example, I am taking here tertiary alkyl halide, that is example 2-methyl 2-bromopropane, that is CH3 Br. This is a tertiary alkyl halide. Means the halogen atom attached to tertiary carbon, that is called as tertiary alkyl halide. Tertiary alkyl halide. Okay. And what is the name of this compound? Means 1, 2, 3. Okay. And these are the substituents. 2-bromo, 2-methyl, 2-bromo, 2-methyl propane. So these 2-bromo, 2-methyl propane and hydrolysis with KOH, we can get tertiary alcohols. This is CH3. This is a tertiary alcohol. Along with what is this tertiary alcohol name? Okay, that is 2-hydroxy 2-methyl propane. 2-hydroxy. Otherwise, we can write as 2-methyl IUPAC name. 2-methyl propanol 2. 2-methyl propanol 2. Okay, now. So this is the example for SN1 reaction, and this will takes place in two steps. This is the two-step mechanism. So how this reaction will take place in 2 steps? Let us see. Okay, now in the first step, step one is the formation of carbocation. So here this tertiary alkyl halide CH3 and CH3 Br. Okay. Then this is the first step and slowest step. Slowly will take place. Then here there is a formation of most stable carbocation CH3, C plus CH3 and CH3. This is the carbocation, carbon bearing positive charge. That too, this is tertiary carbocation. This is very, very stable one along with the Br minus. This is the first step. Okay. So formation of carbocation is the first step. And if you observe the step 2. Okay. So what will happen in step 2? So this stable carbocation, for that carbocation, there is attack of nucleophile. That's why attack of nucleophile, we can get the alcohol, tertiary alcohol. That's why this is called as unimolecular nucleophilic substitution reactions. So here in step 2, we have to observe this step 2 means formation of product. Formation of product. What is that, ma? Formation of product through attack of nucleophile. Attack of nucleophile. So once observe here, this is the stable carbocation. How the nucleophile will attack? So here we can observe the attack of nucleophile OH minus. This is the nucleophile. Nucleophile means which is nucleo means nucleus, means which is having positive charge. This one that allows positive charged one, means this is having the negative charge one. Negative charged species is called nucleophile. So this nucleophile will attack in 2 different ways. Once observed, so here this OH minus nucleophile will attack in front side. We can get the 2 retention product. Okay, now retention means COH, CH3, CH3, CH3. This is called as retention. Retention. Okay, now in another way, OH will attack, OH minus will attack from the back side. So front side means retention we can get, and back side means we can get, back side means we can get inversion. Inversion. Okay, now. So this the part, this is what is the inversion. So in the SN1 reaction, the stereochemistry, we can observe the formation of two configurations, retention and inversion. This is called as resmerization. Enantiomers to retention product and inversion product. So this is called resmerization, and this will take place in two steps. Step 1 is the slowest step and step 2 is the fast step. Once see this SN1 reaction. This is the complete information regarding SN1 reactions. So in the SN1 reactions, once observed on SN1 means unimolecular nucleophilic substitution reactions, and the order of these SN1 reactions is 1, and the order of reactivity of alkyl halides towards SN1 reactions is tertiary alkyl halide is greater than, secondary is greater than primary, and the rate of reaction of SN1 reaction depends only on the concentration of reactants only. And this SN1 reaction will take place in two steps. Step 1, formation of stable carbocation. Step 2, formation of product through attack of nucleophile. Okay, next, if you take one example for this SN1 reaction, tertiary alkyl halides on hydrolysis give tertiary alcohols. So here we will take one example, tertiary alkyl halide, that is 2-bromo, okay, 2-bromo, 2-methyl propane. So that is on a hydrolysis, we can get tertiary alcohol, 2-methyl propanol 2. Okay. Okay. So this is the direct step I written, but in SN1 mechanism will take place through two steps. First one is formation of carbocation. So here this is the tertiary alkyl halide. Okay, there is a formation of most stable tertiary alkyl halide carbocation. This is a tertiary carbocation, most stable one. After that, for this carbocation, there is attack of nucleophile. So that nucleophile OH minus will attack from the front side, means that is a retention product, and back side means that is a inversion product. This is about SN1 reaction. Let us go for SN2 reaction. Okay, I think you understand this SN1 reaction. Okay, then we can see what about SN2 reaction, madam. Okay, so same as if you got this SN1, so some points are bonus for SN2 reaction. Okay. So here SN2 reaction means SN2 means what, Nana? 2 bimolecular. Yes or no? Okay. Bimolecular nucleophilic substitution reactions. SN2 means what, Nana? Bimolecular nucleophilic substitution reactions. Okay. So let us see SN2 reactions. So SN2 reaction. Explain about the SN2 reactions. So SN2 reaction means what, Nana? First point, SN2. SN2 means what? Bimolecular nucleophilic substitution reaction. SN2 means bimolecular nucleophilic bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Okay, whereas SN1 means unimolecular nucleophilic substitution reactions. And here, the order of SN2, what is the order? The order of SN2 reactions is 2. The order of SN2 reactions is 2. And the order of reactivity, the order of reactivity of alkyl halides in SN2 is primary is greater than, secondary is greater than tertiary. Whereas in the case of SN1, tertiary is greater than, secondary is greater than primary. But whereas in the case of SN2 reactions, primary is greater than, secondary is greater than tertiary. Okay, like that you have to revise the concept in comparatively, then we can get the clarity. We should not get any confusion. Okay, next fourth point. Here, the rate of reaction, the rate of reaction, the rate of reaction of SN2 reaction, okay, is depends on concentration of concentration of reactants, concentration of reactants, the same time nucleophile also. Okay, so that's why this is biomolecular nucleophilic substitution reaction. Order is 2. Like that only the rate of reaction of SN2 depends on concentration of reactants and nucleophile. Okay, and this will take place only single step, Nana. Okay, this will take place only single step. But whereas in the case of SN1 will take place two-step mechanism. But SN2 will take place only single step. Okay. And here the stereochemistry you observe means here we can observe the Walden inversion. Okay. Inversion only, inversion configuration. We can observe inversion. And if you observe, the product formation takes place through transition state. Through transition state. Okay. Let us take one example. So what is the example we'll take? So here we'll take one example, methyl bromide. Example, methyl bromide on hydrolysis, methyl bromide on hydrolysis, get methyl alcohol or 1-methanol. Okay, now means primary alkyl halides converted into primary alcohols. Example, if you take this is methyl bromide, CH, okay, then Br, okay, Br along with KOH, then so there is a formation of primary alcohols, OH, okay, and H plus Br minus, KBr or Br minus. Okay, this is the general reaction. If you have to explain the mechanism of this SN2 reaction, mechanism. What is the mechanism means? First, what will happen? This will take place only single step, no? Okay, so this methyl bromide, CH, Br. For this methyl bromide, there is a talk of nucleophile and there is a formation of transition state between the reactant methyl bromide. This is methyl bromide, primary alkyl halide. Methyl bromide, primary alkyl halide, primary. Okay. So here we will see the unstable transition state between the reactant and product. That is CBr, OH, H. This is called transition state. Transition state. After this transition state, we can get our inversion product. That means backside attack of this OH minus SN. This is called Walden inversion. Okay, then what we can get? C, OH, H plus Br minus. Okay, so this is primary alcohol, methanol, UPAC name, methanol or methyl alcohol common name. Okay, methyl alcohol, which is primary alcohol. Okay, so this is the SN2 mechanism. Okay, once observe, this is simple and very easy. If you got SN1, automatically we can easily get the SN2 reaction. So SN2 means what, Nana? Biomolecular nucleophilic substitution reactions. And SN2, what is the order of SN2 reactions? 2. Okay, and the order of reactivity of alkyl halides towards SN2 is primary is greater than, secondary is greater than tertiary. That's why we take it as an example of primary alkyl halide. Okay, the rate of reaction of SN2 depends on concentration of reactants and nucleophile. Okay, so here this will depends upon the concentration of reactants as well as nucleophile. That's why this is called as bimolecular nucleophilic substitution reaction. Okay, now both the concentration of alkyl halide and nucleophile. This SN2 will be depends rate of reaction. Okay, and this will take place only single step. This will take place only single step. Understand? Next here we can observe the stereochemistry. We can observe the inversion product. Okay, now this is inversion product we can get. Okay, this is only called as a Euler inversion. And here this formation of products followed by the transition state, unstable transition state. This is the important point regarding SN2 reaction. If you take example methyl bromide, that is on hydrolysis with KOH to get methyl alcohol. Okay, this is the general reaction. If you take the mechanism, so in this mechanism methyl bromide, this attack of nucleophile from the back side, then through the formation of unstable transition state. After that, transition state after this is unstable one, immediately there is a formation of product methyl alcohol, primary alcohol. So this is about SN2 reactions. So in this session, we explain the differences between SN1 reaction and SN2 reactions. SN1 means nucleophilic unimolecular nucleophilic substitution reactions. SN2 means bimolecular nucleophilic substitution reactions. The order of SN1 is 1. The order of SN2 is 2. Okay. And the reactivity of alkyl halides towards the SN1 is tertiary is greater than secondary is greater than primary. And the reactivity of alkyl halides towards the SN2 is primary is greater than secondary is greater than tertiary. Okay. And if you observe, the SN1 mechanism will take place through in two steps. One is formation of most stable carbocation, and second one is attack of nucleophile for the most stable carbocation. Then there is a formation of product. Yes, sir. What about here? This will take place only single step. Okay. And if you observe, there we can observe the decimation. Means both retention and inversion products we can get. But whereas in the SN2, we can get only inversion product. So you can understand this SN1 and SN2 reactions are clear cut, crystal clear. So I hope you understand my concept in easy way. Please like my channel, subscribe my channel and support me. Thank you. Thank you so much.